slide shows my presentation outline. First, I will introduce Nagoya. Second, I will show the history of technology in Nagoya and its region in brief. Third, I will explain the need for the development of the next generation vehicle. Finally, I will review my conclusions.
I'd like to show this slide. Why USA and Japan? Currently, there are two global issues. As you know, there are depletion of fossil fuel and increase of carbon dioxide. Then Japan regards hydrogen and fuel cell as one of the best solutions of these issues. In June 2014, the Ministry of Economy, Trade and Industry made hydrogen and fuel cell strategy roadmap. I'm going to explain in detail later. In December 2014, Toyota Motor Corporation launched Mirai, the first fuel cell vehicle, into the market. The company has a plan to make 700 and 3,000 Mirais in 2015 and 2017, respectively. Also, Nagoya City Science Museum developed an educational program in order to promote public understanding of hydrogen, fuel cell, and next generation energy.
In this slide, I'd like to explain the experimental operators. This is a fuel cell reaction. Hydrogen reacts with oxygen to generate water and electricity in the presence of a catalyst. Then, electromotive forces were measured with digital tester by two reaction gas supply methods. One is a system using gases injected from gas bags, and another is a system using gases generated by electrolysis of water. In the system using gases injected from gas bags, hydrogen and oxygen were filled in syringes with catalyst. In another system, reaction gases were filled by electrolysis of water using a stabilized DC power system. In each system, oxygen and hydrogen were filled in cathode and anode respectively.
I'm going to show the experimental equipment. Here is a fuel cell which is made in Yamanashi University. Paste, like platinum catalyst, carried on carbon black in a circle, is placed on both cathode and anode in the cell. The diameter is 22 mm and it covers an area of 3.8 square centimeters.
Protective membrane named Nafion. One side of the square is 4 cm in length, and the square covers an area of 16 square centimeters. This fuel cell provides the most electric power of the three in the weaker fuel cell, and made by Yamanashi University cell and this.
Let me show you the Mirai's dynamic system. Please look at this slide. Power control system is located between the fuel cell and the motor. Our one-seat person vehicle follows the Mirai's dynamic system. Usually, AC motor is used for transport because it doesn't need maintenance. However, fuel cells send DC. Thus, DC from fuel cell need to be inverted into AC. Moreover, pulse width modulation control is also needed in order to provide the variable voltage connected to the accelerator. In December 2014, 3 students took part in the seminar in Tokyo on making 3 AC motors with different windings for electric vehicles. On the first day, we made control circuits, including inverter and PWM control system by soldering. On second day, we wound copper wire into 18 coils by hand. Then, 3 AC motors with different windings were made.
Before my explanation, I would like you to remember the second presentator's content. She explained Japan's policy to realize a hydrogen society. Ministry of Economy, Trade and Industry shows the hydrogen and FC strategy roadmap. There are 3 phases. Phase 1 target is growing number of FCV and stationary FC. But this hydrogen is based on natural gas, namely methane. Phase 2's target is introduction of hydrogen power generation. This hydrogen is imported from overseas. Phase 3's target is CO2-free hydrogen supply system. In this phase, hydrogen is generated by renewable energy. There is the hydrogen and FC strategy roadmap.